Good morning, everybody. Welcome back to another live edition of me solving Khan Academy SAT math problems on YouTube Live, as well as Instagram Live. What's up, Instagram Live people? So let's get into it. And today we are solving, center, spread, and shape of distribution problems. So again, more statistics stuff. And as I mentioned before, the SAT is making a huge shift to include more data analysis type problems. And that's definitely represented in the practice problems, rightfully so. Without further ado, let's get started. Jump into the screen share. I got the first problem loaded up. Have not looked at it yet, just glanced at it. Again, I'm solving these problems live with you. So that's part of the fun. Never know exactly what's going to happen or what I'm going to get. But we solve them together as a team. And this is a box and whisker plot. Box and whisker plots are interesting because I got to tell you, I actually didn't learn them. At least I can't remember learning them. I don't think I did when I was in high school or middle school or anything. I've had to learn them as a tutor because not only are they tested here on the SAT, they're also tested on a test called the IC. So I've had to learn them. So let me just explain what this whole thing means. This is the lower bound. So that means the smallest value of whatever this is temperature, right, would be around 25. This is the absolute upper bound. So these two dots, that's the range. This middle value right here is the median, okay, that line right there. And then this is this rectangle from here to here. This is what's called the interquartile range. So down here is like the 25th percentile. Here's the 75th percentile. That's all it is. It's a box and whisker plot. Now let's get down to business. It says the box and whisker plot above shows the average outdoor temperature of a North American city at noon in degrees Fahrenheit for each month of the year. What is the range of the temperatures? Now, again, I said the range is defined by these dots. So we just got to try and figure out really nicely. This is 25, and I think this looks like 87, I'm guessing, or 88. So that range is the difference of the highest and the lowest. So it should be about 62. And they said 61. So I think they're marking this at 86, not 87. But this is clearly the only one that can fit. So our answer in this case will be C. We got it. Let's go on to question number 2. Question number 2. Boom, boom. Let's get rid of this. Let's get rid of this. And we have printed much bigger this time, which is better, clear. Percentage of population supplied by water supply industry. And this is kind of like a histogram. A histogram is where each one of these dots represents like a person or something, or I think in this case, a country. It looks like countries, right? So this means 2 countries are at 30, now let's read the problem and see what these values actually mean. A census was taken in 11 African countries. For each country, the amount of the population that had access to water from the water supply industry was computed and recorded to the nearest 5%. Oh, I get it. This amount was expressed as a percentage of the total population and plotted above. According to the dot plot, what is the range of these percentages? Range is just lowest, which is 30, to highest, which is 100 over here. So that means the countries with the least amount of access to water was this right here, 30%. Over here was 100%, excuse me. Therefore, the range is the difference of those two values, which should be 70%. So let's go ahead and put it like this. We don't add a percentage symbol or anything. We just should put 70. That should give us the right answer. And yeah, it does. And that's exactly what they say in the explanation. Let's jump into question number 3. Let's delete this. Here we go. Question number 3. And if you're watching on Instagram, guys, thank you so much for watching. Make sure to jump onto my YouTube channel so you can see the problems being solved. Go to YouTube, search for Scalar Learning. You can still jump on the live stream right now. The number of employees in each industry in Seattle was recorded and rounded. Number of employees, okay. Recorded and rounded to the nearest 10,000. The results are displayed in the dot plot above. According to the dot plot, what is the median number of employees in thousands? Okay. So it's like median, we take all the values and we find the exact middle one. This is my strategy. First of all, let's see if it's odd or even. Assume it's odd. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Perfect, because then we have an exact middle. So how do we find the middle? Well, I'll go like this. Cross off 1, cross off 1. Cross off 1, cross off 1. You see how I'm doing this? I'm kind of going up, and here I'm coming back down. Cross off 1, cross off 1, cross off 1, cross off 1. Okay? This, this, and there's our median. Hope that made sense. It's kind of like if we laid these all out, if we laid them all out, it would be like 0. Then it'd be like 10, 10, 10, 10, 10. Then it'd be 20, 20. Then it'd be 130, 2 40s, no 50, 170, and 190. This might be a little easier if you want to write it out. And then we go 0, 90, 10, 70, 10, 40, 10, 40, 10, 30, 10, 20, median. And again, it says number of employees in thousands. So we don't put 20,000. You want to be really careful of that. On the actual test, if you do, you can't because there's not enough room. You just put 20. That's your indication. If it's beyond 4 digits, can't do it. So 20, there you go. Question number 4. It says, let me copy this. Copy this. And let's see over here. Boom. All right. Data was taken on carpooling in Tallahassee, Florida. For each person's daily commute, the number of people in the car was recorded. The results are summarized in the bar graph at left. What is the median number of people in the car? Okay, so we want median. And wow, look at this. This is crazy. In this case, it's kind of obvious. Like we have so many people that are ones. If we were to like write this out and quantify it, but you don't even need to. Again, it's that middle and sort of like the middle of all these guys, almost like that 50% mark. And since more than half the people are in the 1, it would be like if we wrote this out in a bar model, okay, it'd be like this. Let's see if this works. So it'd be like 1s are all of this. This is the 1 zone. And then it's like 2 might be this little chunk, and then 3 and 4 are like well, it's a little out of order, but this would be 3, this would be 4. So you can see if we're going across, we'd go right here to the middle point. Middle point's 1. I mean, we're still in the 1 zone. So in this case, you don't need to do much. Let's see if we're right. And that's it. That's basically it. Last question of the day. Now, normally these videos are going to go out on the weekdays, Monday through Friday. Yesterday, I had a little issue with the recording, and I had to stop midway. So I removed that video, but now I'm doing it today on Saturday as a makeup. So sorry about that, guys, if you were expecting a video yesterday. Now we got question 5 of 5. It says maximum rainfall for the year in centimeters. Again, this is a histogram, right, where each one of these dots represents a person or probably a region that gets this, I assume. Let's see. Was recorded over a 41-year, it's a year, 41-year period in Turamura. Don't know if that pronunciation is right. For each year, the day with the most rain in centimeters was plotted above according to its amount of rainfall to the, no, sorry, this is centimeters, not years, to its amount of rainfall to the nearest 2 centimeters. According to the dot plot, what is the maximum amount of rainfall that was ever recorded in a single day in centimeters? I got to tell you, this one is just basically reading the graph and understanding that this is in centimeters and this is the rainfall. Maximum is this value. The most we ever had is 38. If you can read this and understand, it's not so bad. I think they might be attempting to see if people choose this accidentally, I think, right? Because that's the one that has it's the most frequent, it's the most common. That's the mode, essentially. But the most amount of rainfall is right there at the end. It's 38. So we should go ahead and hopefully this should be good to go. And yeah, that's it. So that's all we got for today on this Saturday. Let me jump back here. Oops. Turn off screen share. All right, that's all we got today. So I hope that was helpful, guys. And again, I've got all sorts of SAT problems on my channel. So if you like this video, like it. And you should definitely subscribe because there's a lot more to choose from, a lot more help that you can get on this subject of the SAT. So we really want you to check this stuff out and benefit from it. It's all free for you to peruse. So thank you guys so much. If you have any questions, don't forget you can always email me at huzaifa@scalarlearning.com. I will happily get back to you. Thanks so much, and I will see you guys next time. Have a great weekend. Take it easy.